The day is September 2nd, 2023. Not even a week after the landing of the Chandrayaan-3 rover on the surface of the South Pole, the Indian Space Research Organisation is once again tense for the launch of another equally important spacecraft. But all these concerns, stress, and tension in the atmosphere vanished after this relieving signal.
Plus 5 seconds.
Liftoff normal.
P1 tracking.
PC tracking.
Magnificent liftoff of PSLV C-57 with Aditya L1 on board.
As India's solar mission started its 1.5 million kilometer journey towards the Sun. After 4 months of space travel and gravitational maneuvers, the Aditya L1 spacecraft reached its destination. But reaching this point wasn't as easy as you might think. In fact, reaching this point, and more importantly staying there in a stable configuration, is considered one of the most difficult procedures in solar system exploration. So how did India pull this off? And more importantly, what is the significance of this point in the solar system, called Lagrangian Point 1? It starts with gravity. The solar system is a vast array of planets, asteroids, comets, moons, and other bodies that all interact under one force: gravity. Gravity is in fact the reason why the solar system formed the way that it did, because all of the tugging from each of the planets, the Sun, and other small bodies aligned the solar system into a disk. The first person to describe gravity was Isaac Newton under his famous law of gravitation, which, when applied to objects such as the Earth, give both the gravitational acceleration of that object at any given radius, but also the velocity of any satellite orbiting the object at any given radius. The interactions of gravity were somewhat understood by Johannes Kepler and Galileo Galilei. Kepler created laws to describe the motion of objects in systems such as ours, while Galileo used Jupiter's exertion of gravity on its moons to argue for the idea that the Sun is in the center of the solar system, not Earth. These gravitational interactions are used by spacecraft to their advantage, such as the Aditya L1 mission. A famous example of this is the Voyager missions from the 1970s, which used the gravity from Jupiter, Saturn, Uranus, and Neptune to study the outer solar system and eventually escape the solar system entirely. Not only can gravity be used as a slingshot for spacecraft, but they can also be used to keep spacecraft in a stable configuration for long periods of time. That is why Lagrangian Point 1 is so useful. Lagrangian Point 1 is one of the many points used by astronomers to place spacecraft to study the Sun or the cosmos that surrounds the Earth. Why? Because at this point, at Lagrangian Point 1, the gravity exerted by the Sun and the Earth cancel each other out, leaving the spacecraft in a stable configuration. Instead of putting satellites precisely at Lagrangian Point 1, which would only allow for one satellite at that point, and would also be extremely difficult to keep that one satellite there, scientists instead decided of something far more practical, yet far more difficult. Satellites at Lagrangian Point 1, such as Aditya L1, never stay precisely at the point, but rather orbit around that point in a stable orbit. It is precisely why this mission, and many others like it, are so difficult, because you have to make a satellite orbit around an invisible point that can only be determined by the most precise of calculations. As of now, there are 4 satellites currently positioned at Lagrangian Point 1. The European Space Agency's solar mission, named SOHO, is studying the Sun like Aditya L1, specifically the Sun's outer atmospheric layers like the chromosphere and the corona. SOHO is also probing the interior of the Sun and trying to understand the mechanisms that drive the Sun inside. The ACE mission by NASA is currently studying energetic particles that rush away from the Sun in what astronomers call the solar wind. Think of this study as basically solar system-wide weather forecasting, and in case of bad solar storms, we can be prepared. There are many other missions there to study the Sun, and Aditya L1 is no different, being India's first solar mission. The fact that India got to this point on their first try is similar to everyone's expectations of India getting to Mars on their first try. No one was expecting it, and yet India showed that they could do it anyway. But how do we get things into space? Well, if you want to deep dive into the physics, mathematics, and logic behind why we do space technology, then just click the video you see on your screen. By the way, if you aren't already, do make sure to join the Discord, because there you get a chance to discuss all kinds of cool science with me and much more. Join now using the link in the description.